Welcome to the last, I guess, 2.5 weeks of the course, and we're just going to keep chipping through some of the Python materials. I've been receiving several of the Python exams and going through them. Yeah, Maria, so close to summer. And so I will continue to do so. Just another reminder that that test is due at 11:59 on Wednesday, and that one can't be postponed or submitted late. So make sure that you attempt everything you can. And if there's something you're not quite sure about, just do your best and hand it in just to make sure that you can get some partial marks. I'm a big proponent of giving partial marks. So that sort of takes care of the first unit exam. And then next week on Monday, we start the second Python unit exam, which actually is normally reasonably well done because a lot of the concepts carry over from the first exam, and then we're just adding in a few more things regarding looping and lists and dictionaries, which we haven't gone through yet. So if you do well on unit exam 1 and you're able to follow what we're doing here in 4.5, 4.6, and 4.7, you'll do very well on the second unit exam as well. There's no final exam in the class, so that's the last unit exam that we've got. And the only thing after that is there's a quick careers assignment and then your final project. So we're getting near the end. Lots of people have sent me ideas for their final projects, and I do appreciate that. I've tried to give you some feedback on your ideas and maybe how you can improve them or extend them, or give you some feedback on if it's an appropriate challenge, or if you might need to add a little extra work in, or a few extra functions. But generally speaking, if it's something you're interested in and it's clear that you've put in an appropriate amount of time, and if it's a programming assignment, you've demonstrated the 5 basic principles and skills: input, output, variables, data types, storing information, looping, and repeating, conditionals, so if, elif, else, and the final thing is functions. If you've demonstrated those 5 things in any way, shape, or form on your project and used them effectively, the marks are generally very high. So good luck with those, and again, I'm available to answer any questions you have about them. So last week, I had some students say that they were moving on and they wanted an extra live session on looping. So I actually built a lesson on looping, and it's really detailed, it's really in-depth, and it should hopefully answer any of the questions you have with looping. And I put that up on Friday, so the live session recording is available in Unit 4. And I'm hoping today just to do a quick looping review. Now, I understand that many of you would not have had time to check the work or to check the recordings out and go through it. So I think it's really important today that when I'm doing the looping review, if there's anything that really stands out for you that you just don't get it, feel free to interrupt me and I can try to move through it again. But I just wanted you to be aware that there is a very in-depth recording of a live session that I did on Friday that handles looping. And no, I didn't advertise that because it was kind of an impromptu thing that just kind of happened. So if you missed it for whatever reason, which is frankly to be expected, don't worry about it. Go back and watch that video, and I think things will be quite clear. But as always, I'm available via email, or I can set up a live session, or whatever you need. So I'm sort of hoping to go through the looping quickly because we can just do the strings, which is 4.6, is a very, very short unit. And then you'll have another live session on Wednesday where we go through 4.7, which is dictionaries and lists. The lists are the really important part of that because it's the handiest way for us to store information in a Python program, which is something that we didn't have to do in Reboard. We didn't need to store any information, so you have no experience with lists. We did introduce lists very briefly in Scratch. If you remember the one where he steals or takes the computer and the bowl of cheesy poofs and whatnot, it was adding those things to a list. So it's the same idea, and it's going to be really important for that last exam. So I wanted to make sure that I was able to get through that by Wednesday so that you've got lots of time to complete assignment 12, I believe, which includes lists, and then be ready to start that Python exam on Tuesday next week and be confident that you've got all the Python skills and experience that you need. Okay, so again, don't hesitate to stop me or slow me down if I need to go into a bit more detail, and also be aware that there is a lot more information on looping already available if you're able to watch that live recording at some point today. If things make sense in those live recordings and you're just kind of chipping through it on your own time, and you're make sure you're testing things out in Python as you go along, because just watching the skill doesn't really reinforce it for you. You got to practice and make up some of your own examples and whatnot. So do make sure that you're doing that. And if things are making sense and you're just kind of rolling along, in the settings section, I've got them all posted up on YouTube. And in the settings for the video on YouTube, the little gear thing, you can increase the speed to 1.5 speed or 1.75 speed. I start sounding a bit like a chipmunk, but it goes through the content quicker. So you can turn an hour 15 video into 30 minutes or 45 minutes, as long as you're understanding the concepts and you're able to replicate them. Are there any other questions about that? Are there any questions about anything else before I get into this? Thank you. Not seeing anything significant. People say they're fine, so I'll keep going. But you know the drill. If you have any questions or concerns, you just send me an email, and we'll figure out some way to help you move forward. Okay, so here's the sort of quick review for looping. We've got two types of loops in Python that we use. One is called a for loop, and then one's called a while loop. And we've done lots with while loops inside of Reborg, and it works very similarly in Python with regard to the syntax and the words and how you set them up. The for loops are different, okay? So in Reborg, the for loops were called repeat, and you would just do like repeat 5 or whatever, and then do whatever you want to do. The concept is the same in Python, but it's different words and different structure to how you set it up. So we're just going to start with for loops, because that'll be newer material for you. There's a couple different kinds of for loops. I'm just going to set a variable here, and I'm just going to call it word1 equals Python. And the first for loop is very simple structure. Any one of your for loops is going to start counting at 0 and then go up to a certain end point. So it's going to loop that many times. And there's a bunch of different ways for you to tell it how many times to loop based on your variables or whatever data that you want to loop through. The big rule for loops, the thing you've got to ask yourself at the very beginning of the process when you're deciding what kind of loops to put in your program and assignment, you have to decide, do I know how many times this program needs to loop right off the bat, or is the user going to give me information that I need to use to determine, how many times I need to loop? Because if you know how many times you need to loop, or if it's easy to find out how many times you need to loop, you should always be using a for loop. Okay, if you don't know how many times your program needs to run, you should be using a while loop. So that's the question you have to ask yourself before you insert a loop into your program. Do I know, or can I easily find out how many times I need to loop? Or does the user kind of control how many times I need to loop? For instance, if I was doing a countdown from 10 to 0, and then I was going to print blast off after we get to 0, I know how many times I need to loop that program, so I would use a for loop for that program to count down, because I know where to start and I know where to end. However, if I were to give a program where you have the user type in their grades, this is one of the assignments, you can have them type in as many grades for a class as they want, and then you'll give them an average of those grades. Well, when the program starts, you don't know how many exams they're going to enter. They could enter 2 exams and you give them an average, or they could enter 100. So because you don't know how many exams they're going to enter, you need to use a while loop so that it loops as long as it needs to until it reaches the final item. So you always ask yourself that question. Now, the simplest for loop is just if you're checking, if you're just checking how many things are in a string or in a list or in a sentence or something like that. And it's very simple. Let's say we wanted to take Python and print 1 character per line, and we can do a for loop that just says for letter. And now this is a variable, and it can be anything you want. It could be X, it could be Y. It's a local variable that's only going to be used inside this for loop. So it didn't matter that I called it letter. I just called it letter because it kind of makes sense in the context of the loop. So for letter in word one, and it knows what word one is because I hard coded it above. Word one is Python. And then all I need to do down here is I just need to print letter. Now make sure you're printing letter, not word one. Otherwise, it'll just print word one 6 times. In this case, it's going to start at the beginning letter or the beginning index for whatever it is, and then it's going to print that particular letter. So it's going to print P first, and then in the for loop, it's built in that it knows to go to the next thing. So it's going to print P, then it's going to print Y, then it's going to print T, H, O, N. Once it gets to the end, it knows it's done, and then it just moves on to the next line of your program. So I'm just going to have a print program finished, just so we know that it's actually it's completing the loop, it's getting to the next line in your program, and in this case, complete. So this is a very, very simple loop, and I'll just run it for you in step-by-step mode so that we understand what's going on. Okay, so we got word one is Python. There it is. It knows it's a string. It knows it's Python. Now, when I set my loop, you notice that the letter variable for the first time it goes through the loop is a string, which makes sense, and the value is P. So it just starts at the beginning of whatever word one is, and it's going to print that. Then when you go up to the loop again, the next time through the loop, the second time through the loop, it knows to move to the next letter in the word. And that's Y, and then it's going to print Y, T, H, O, N. Once it gets to the N, it knows that it's at the end of the word, so then it goes to the next line in your main code, which in this case is just going to tell us program finished. So that is, this is for later in the session. I just want to comment them out for now, so then, keep breakpoints in. Just run. So that's about as simple as a for loop will be, and that's the equivalent, I would say, of the repeat loop in Reborg. Again, letter is just a variable. If I put for x in word, x is just going to represent the character at whatever loop you're in. So in the first loop, your character is going to be, or your x is going to be the first character. The second loop, it's going to be the y and whatnot. So it doesn't matter if I change it to x instead of letter. Letter doesn't mean anything special. It's just a variable name. It runs the exact same way. It doesn't matter what you call your variable. So a lot of people just put for x in whatever, and that's fine as well. But I generally like to include variable names that actually mean something or indicate what the data is that we're using. So that's about as simple as a for loop gets, just for some variable, which is going to be a number. By the way, in this case, letter and in this case, when you're using a for loop, x is usually standing in for a number that starts at 0 and goes to wherever, because we know that our computer science, our programming languages start counting at 0. In this particular case, when you do a for something in a string, it treats x as the character, not as a number. So something to be aware of. So that's a very, very simple loop that'll allow you to go through any given string and just print out the character. And it doesn't matter what the word is or how long it is. It's gonna loop as many times as it needs to loop to do what we ask it to do, which in this case is just print the characters one per line. If, for instance, you want to go through and make a single string so that it's not printing out one character per line, you can use something that I just refer to as a temporary string, and I usually just call it temp string. And then you can set it to that. So let's just say I had a string and I wanted to rebuild it. So I have this string word one called Python, and let's just say I want to go through Python and add each character one at a time to a temporary string, so that at the very end of my loop I can print out the entire string again. Basically, the idea here is I'm just creating a temporary string that I can add characters to, so that I can print it out on one line at the end instead of printing one character. So in this case, maybe instead of printing x, I'll just print a message that says I'm adding whatever x is. I'm adding this letter to the temp string, just so you can see what's happening each time. And then at the very end, I'll print out temp string, and it should be the same thing that we entered in as words. But instead of just printing word one, we're actually creating a new string where we're adding things to it. based on our loop, and then at the end we'll print out temp string. If we get the same thing that we entered originally, we will know it's worked properly. Now, this program obviously doesn't make a whole lot of sense, because if you wanted to print out word 1, you just print out word 1. But there are going to be cases where you're going to have to use loops to continually add letters to a string, or when we get to lists and storage things, continually add items to your storage list. And this is sort of a way to do it, particularly with strings, because it's, you know, generally of limited use to people to see things printed vertically, one line at a time or one letter at a time. So let's do this one here, and we'll use Python again, and I'll step through it just so you can see what's happening. Okay, we've got our word 1 equals Python, and we've got a temp string, which is also a string, and you notice the value is essentially nothing, just the quotes right now. So we're going to add to that temp string 1 letter at a time. So for X in word 1, so it knows where to go. It knows to go to Python, and it knows that it's going to start with the first character. So it's going to print, X once again is P. It's going to print, I'm adding P to the temp string. And now when we look at our temp string over here, oh, I forgot one important thing. I created my temp string and I printed my temp string, but I didn't actually add anything to it. So I need to add to my temp string as I go along here, right? So temp string is starting at 0, and then we're going to use the short form of adding to it. So our temp string is going to be plus equal X. So every time it runs through the loop, it's going to add another character to the temporary string. Okay, so I'll start that again. Okay, so we've got temp string. All right, so first time through, our value is P. It's going to say I'm adding P to the temp string. Then this is going to take temp string, which is 0, which is nothing, not 0, it's nothing. And then it's going to add a P to it. So now when I go to the next loop, because it'll be on the Y now, if you look over here at my temp string is now the capital P. Okay? And it also printed out I'm adding P to the temp string. Now for the second time through the loop, it's just going to go to the next letter, which is Y. So it's going to say I'm adding Y to the temp string, and then it should add Y to the temp string. And we notice it did over here. Temp string is now PY. Okay, now, and we just keep looking through. It's just going to keep doing that until it gets to the end. And at the end, your temp string should be the same thing as what we started out with. And then it prints out Python at the end. So it looks like we just printed out word 1, but what we really did in this is we used a loop to populate temp string with all of the letters in whatever word it was. And then it told you, I'm adding this, I'm adding this, I'm adding this. And at the very end, it printed out Python. I'm adding O to the temp string. I seem to be missing a line that I'm adding N to the temp string. That's strange. That's strange. Maybe it just didn't run yet. There it is. Yeah, I don't know why I didn't print this last line out last time. It seemed to be fine, but now it's good. All the letters of Python are there. Prints out the temp string at the end. Then we know it gets down to the very end of the program. It says temp string is not defined. Did you up here create an empty variable that says temp string equals empty quotes? Because if you don't have a variable called temp string, you can't add to it or refer to it in any way. And make sure all the characters are the same and spelled the same and all the cases the same. Let me know if that works for you. Usually when it says something's not defined, it just means that you haven't created a variable for it, or you maybe created the variable too far down in your program. You want to have most of your variables at the top of your program, because if you have temp string down here, if you don't note that there is a temp string until down here, it tries to do something with it right here before it's actually read that there is a temp string. So that's why you want to have it up at the top. When you get a chance, let me know if that worked. So that's 4x in word 1. So those are relatively simple loops. Now what we're going to do is we are going to show you something where we're using numbers instead. Yeah, that's generally what the case is, Jeanette there. Now we're going to use a different type of for loop where we're using numbers. In this case, we'll use integers instead of a string. So it's very similar. It starts at 4. And it also gives you a chance to put in a variable. You can put in X or Y or whatever. I'm just going to put in num because I'm going to deal with numbers here. And this is the new word here, is range. Okay, so when you're counting up or down in your loop, you're going to use something called range. And range by default starts at 0 and goes to whatever number you put in the bracket. So for instance, if I want to make a program that counts from 0 to 10, I would put in for num in range 11. And I'll tell you why in a second. And then I'll just print whatever the num is. All right, so in this case, num is going to start at 0. Okay, and then it's going to go up to 11. So it's going to loop as many times as it needs to hit this number. Now, here's the thing you have to remember, and I've made note of this in the other video many times. It's always going to stop one before that. So because what happens is it gets to the top of the loop, and as soon as num equals 11, it doesn't print this line. Okay, so as soon as num hits 11, it skips over this line. So if you want to print something that goes to 10, in this case, you have to actually put your loop set to 11, so it prints 10 and then stops at 11. And remember that if you just have one number in the range, it's going to start at 0 every time. It's not going to start at 1 because of the way that computers count. So if I run this for num in range 11, num is going to start out as 0, it's going to print 0. Then num is going to be 1, and it's going to print 1. And num is going to be 2, and it's going to print 2. Essentially what's happening up here is it's constantly running a Boolean check. It's basically like an if statement, right? So it's either going to be true or false. Well, either going to be true or false. Either your number is still in this range, and then we're going to print num, or your number is outside of this range, and then this whole line becomes false. And as soon as the for line becomes false, it knows it's done, and it skips to the next line in your program. So when I run this, it's just going to start at 0, and it's going to count all the way up to 10, and it's going to print one line or one number per line. So it should be 0, 1, 2, 3 up to 10. So you see that's exactly what it did. Started at 0, printed it, and then just went to the next number, next number, next number. So the default in a range statement, a for range statement, is that it just adds one number to num every time. So it starts at 0, and then it checks 1, and then it checks 2, 3, 4, and whatnot. If you want to start at a certain number and end at a certain number, and this only works for integers, by the way, you can't do this with any floats. I can't say start at 1.1 or go to 1.1 or anything. It doesn't work. So if you want to start at a certain place and end at a certain place, you put the starting number and then a comma, and then the ending number. So in this case, let's say I want to count from 3 to 6. I would start at 3. It always does print the first number, but then it stops, remember, 1 before the last number. So if I want to print from 3 to 6, I'm actually going to put 3, comma 7. So as soon as you have two numbers in here with a comma, it knows there's a starting point and an ending point. So when I run this, it starts at 3, and then it ends at 6, which is what I wanted it to do. But I had to make sure that I put that in 7. You may make a few mistakes with that, but you'll understand pretty quickly through your output or your debugging why it's doing that extra loop, or why it's doing one fewer loop. So that's how you start at a certain number and end at a certain number. And now we're into, these are handy because, it doesn't take a computer very long to do anything. So if I start at 3 and go to 1,000, it's going to take me a lot less time than it would have taken me to print that out on a piece of paper or something like that. So once we're into looping, we're really getting into the part of computer programming where computers, or the machines and our programs, are really starting to get more efficient. So now they're really starting to help us do things that would have taken us a long time off of a computer if we were just doing it on paper or something. Most of the assignments in the first program would be just as easily done on paper with pencil as it would have been done with a program. Okay, so once we start introducing looping, now we're opening it way up, and we're making it so that we can do programs with huge numbers of strings and huge numbers of calculations or processes or whatever it is we need to do. And this is where we really start saving time. So we've handled range with one number, we've handled range with two numbers. Now there's also a step feature. A step feature just means it's going to count up or down by whatever you want it to count up or down by. So for instance, in this one, for num in range, I'm going to say I want it to print out from 1 to 9, but I want it to skip. I want it to skip 3 numbers every time. Actually, I'll make it skip 2 numbers every time. So if you have 3 numbers separated by commas inside a range, it's your start point, your end point, and then the third piece of data is what do you want to skip by? The default is 1. The default is just that num goes up by 1 every time. But if you put in that third number, now it's going to jump. Num's going to jump up by 2 every time. So it's only going to print every second number. So it's going to start at 1, then it's going to print 3, then it's going to print 5, etc. So I'll step through this one just so you can see what's happening. For num in range, num is going to start at 1 because I told it to. And now, the second time it jumps through, look that you'll notice that num is now 3. So it skipped right over 2, went to 3 because I told it to step up by 2 each time. Now it's going to print 3, Now it's going to print 5, 7, 9, etc. And then once it hits 11, 11 is outside of that number, so it's not going to print the last time, which is why it only went to 7. It should have printed 9. Maybe I'm not done my program. Yeah, there we go. Forgot to hit F7 one more time. And now that num is going to be equal to 11 after this line runs, it knows that this is now false, so I should go to the end and run my last line of the program. And you can step up or down by any value. So if you step up by 4, for instance, it's going to print 1, then it's going to print 5, then it's going to print 9, and then it's done. So that step value is important. You can also use range in reverse. If you start with a higher number and go to a lower number, okay, you can print things in reverse instead of forward. So in this case, instead of counting from 1 to 9, it's going to count from 10 to 2, because remember, it's going to stop 1 before this. It always does the first number, and then it stops 1 before this, and that is in reverse order as well. So it is going to print 10 on this case, and it's going to go all the way down, and it's going to stop at 2. But if you're putting in a reverse loop where you're going to start high and end low, you have to put in a negative step value. Otherwise, your program's going to loop forever, and it's just going to break Python. So this is the situation where you might get into a case where you put in something that's supposed to work backwards, but if you forget to put in a negative step value, it's going to break right away. It's going to loop forever because your num is going to start at 10, and then it's going to, because there's no step value, it's going to think it should go up. So then your num's going to be 11 and 12 and 13 and 14 and whatnot, and it's either going to have an infinite loop, or in this case, it's just not going to run because you're going to print 10, and you're never going to get to 1 if you're counting up, right? It's going to be 11, 12, 13, 14, 15. And it's never going to get to 1, so your program's going to loop. And in most Python IDEs, PyScript or Thonny, whatnot, it'll just run for like a minute or 2, and then it'll eventually kind of crash, and hopefully you don't lose any work or whatnot. So infinite loops are bad. You want to avoid them at all costs. So if I want to count down from 10 to 2, I'll put in a 0, so it maybe goes to 1 instead. You just put in a negative number. So this means num's going to go down by -1 each time. So num's going to start at 10, then it's going to go to 9, 8, 7, 6, etc. So you see it started at 10 because I told it to, and then it stops at 1 because remember, it always stops 1 before this one. And it's stepping down by -1. That's why it's going backwards by 1. Now, if I want to go backwards by 3, I can just put a -3 in there, and now I start at 10, I go to 7, 4, 1, and then the program's finished. So you can step up or down. Just remember, if you're doing a negative step, you have to start with high number, go to the low number, and then step down instead of step up. What if you put -0 so it prints 0, 2? Actually, I think you'd have to put -1 because you want it to stop at 0, and I don't think it recognizes a -0 because that doesn't really mean anything. So here we go. Oh, it printed. Oh, I've got a 1 instead of -1. That's why. So this case, you see it printed 0 because I told it to stop at -1. So it's counting down. So it went 2, 1, 0, and then it got to -1 and it stopped before it could print the -1. So if you wanted to include the -1, you can have negative numbers down here too. It's just an integer, right? I could put -4 if I wanted to, and it'll count down to -3. So it's just integers. Just remember the order. If you're going from low to high, it's positive numbers. If you're going and a low number first. If you're going from high to low, you got to have the higher number first, the lower number second, and you got to step down by negative numbers, whatever it is. You can skip negative numbers just as easily as positive numbers, or you can skip going downwards as easily as you can going upwards. So for num in range, we've seen how that works. I'm going to show you how you can make this work with strings. Okay, so I'm just going to put in word1 again, equals Python, and I'm going to show you how you can use range with strings. Now we know, I'll just look down here for a second, we know that when we're reviewing index with strings, that you can count up or you can count down and reference any particular letter or any chunk of this word using string slicing, starting counting at 0. So the 0 index of the word Python is P, the 1 index is Y, 2 is T, etc., etc. Or you can start counting at the back. The last character of your string is always going to be -1, and then the second last is going to be -2, 3, 4. So you can either go forward or you can go backwards. And we can always print out a string by referring to the slice of the string or just one single character. So for instance, if word1 is Python and I print I print word 1, and then in the square brackets, I print 1. It's going to print the y because the y is in the 1 character. And forget the loop for now. This is the important part here, is that it's just going to print the y because I just asked it to print the number 1 index character, which in this case is the y. So if you remember that, and you remember string slicing, if I print from 1 to 5, it's going to print out YTHO. So you need to know string slicing. I'm not going to review that. But where this comes into play with a loop is we could do the for letter in Python, or we can also use range. But if we're using range, we have to remember that this variable is going to be a number, not a letter. So if we're using range and we know that that number is a letter, what we can do is if we want to print out the entire word letter by letter, like we did before, line by line, you can print num in range from 0, which you don't have to put in, because remember, if you put in one number inside your range, it assumes you want to start at 0. So we want to print from num equals 0 all the way to num equals 5, because n is the 5th index. Okay? And we can use a length for that. So if we put in len of word 1, it's going to go from 0 to whatever the length is. And in this case, the length is going to be 6. So it's going to go and print 0, 1, 2, 3, 4, 5, and then it's going to stop at the 6th character, which is what we want it to do. So now instead of printing the number, I could print the number. It's just going to print 0 to 6, or 0 to 5, sorry. We need to remember that this variable is actually a number. So if I want to print a letter from this word, I have to refer to the variable, which is word, and then in brackets, square brackets, I put the num, because num is just going to be replaced with whatever this number is. It's going to start at 0, so it's going to print word 1 0, which is p, and then the next time through, it's going to be 1, and it's going to print y for word 1. The 1 index in word 1 is going to be the y. So this is a different way for you to print off pieces of strings using numbers and the index instead of just putting for x in Python or something. So just be aware of that. If you're using range, you got to remember that this variable is going to be a number. So if you want to use that number to print something off from a string, you have to include that in square brackets somehow, either as a slice or just as a number. So you see how I printed Python and the program finished? It did that because even though I have length of word up here, length of word is a number. It's not a string. The length of the word is 6. So it's really just saying for num in range 0 to 6, print out the index, whatever num is in that particular loop. Okay, so that can be an important way that you access a word or pieces of words or whatnot. And you could do the same thing with the step value too. So if I were to go step 0, comma, length of word 1, so starting point at 0, going to the 6th index, which doesn't exist, so it's going to stop at 6. It's not going to actually try to print it. And then I go up by 2 instead. Now I'd be printing every second letter. So this is the way that you could print every second letter in a word, because it's going to start at p. So it's going to start at 0, so it's going to print word 1 0, and then it's going to skip to 3. So now for num in range, num would be 3, so it's going to print the 3rd character, which is should be 3, but it starts. Oh no, sorry, it started at 0, so it's going to print the 2nd character, which is t, and then it's going to print the O because it skips over the H and whatnot. Or you can get it to print every 3rd letter by putting in a 3, so it'll start at P, and then it's going to skip from 0 to 3, which is going to print out H, and then it's going to try to skip to the 6th, and the 6th doesn't exist, so that the program's finished. So that's a handy way that you can use for loops with strings as well. And that's pretty much what you need to know for loops. And again, there's a bit more detailed information in that video I made on Friday. This is actually more time than I wanted to spend on it. Maybe duplicating a lot of information today, but it is what it is. While loops, very similar to the way we work in Reborg. It's going to be while there's some condition. We're going to do something, and we don't know how many times that's going to happen. So oftentimes, you use these while loops when you're dealing with user input. They have to tell you something. In this case, let's say, what do you want your countdown to be from? So we'll do like a 3, 2, 1 blast off kind of thing, but we'll let them decide. When to. Actually, no, that would be a for loop too. Sorry, we'll let them type in numbers until they're done typing numbers. So we don't know how many numbers they're going to type in Could be just, you know, any random number they want to put in, but we don't know when they're going to stop. The way that we tell when they're going to stop is we need to have something called a flag or a sentinel. And I usually just, they mean the same thing. I usually just make a variable called flag equals, and then I set it equal to whatever value I'm going to ask them to type in. So I'm going to type in flag equals 0 for now. Sorry, you put in generally what you don't want them to type in. So what I'm going to do here is I'm going to put flag equals 0, and I'm going to put a little input statement inside a while loop. So I want this loop to go on until they enter a -1. So while flag does not equal -1. Okay, so remember that's going to be either true or false. Either the flag is going to be equal to -1 or it's not going to be equal to -1. And I put a 1 instead of -1. Okay, so what I'm going to do within this while loop is I'm going to get some input. So I'm going to say num equals input, and it's going to have to be an integer. If they enter a float, they're out of luck. Input, and then my input message to them is enter any number to print. So they can enter a number, and then, I'm going to print the number, and then it's going to go back to the loop. It's in the bracket there. 1, 2, 1, 2, input, print. I think that should be okay. So the flag sets at 0. So when it runs the first time, it's saying while your flag is not equal to -1. Well, that would be true because 0 is not equal to -1. So it's going to run the loop. Then it's going to ask them for an integer, enter a number to print. They're going to type in a number, and then we're going to print that number, and then it's going to loop back up because I guess I should call this flag. I'm sorry. Flag equals flag. So the flag is going to be the number that they enter in. It's going to print it, and then it's going to check flag up here. And if flag is -1, it's going to go to the end of the program. And if flag is not equal to -1, it's just going to keep asking for numbers to print out. So I'm just going to print out a program finished here, just so I know when it gets to it. All right, so here we go. It's going to run the loop. It's going to ask me to enter any number. I'm going to say 4. So I didn't say -1, so it should print it and it should ask me again. So it does. It asks me for a number. I say 67. I'll do 99, the Great Gretzky. And then finally, I'm done. So I have control over this as the user. I'm going to type in -1, and now it should recognize that they typed in -1, which means that this is false now. Does the flag not equal -1? Well, -1 does equal -1, which makes this false, which means it skips out of the loop and prints program finished. So that's one way you can use a while loop. And the idea of the while loop is that you don't know how many numbers they want to type out. So you have to build your program in a way that it's flexible enough to print out whatever they want, and then they can tell you when they want to end. Okay. Now, the one thing about this loop is that, or the way I've got this loop fashioned, is that it prints out the -1 because it goes to the print flag before it checks whether or not the flag is equal. So you enter a -1 on this line, on line 9, it prints it out here before it checks and knows to exit the loop. So if you have, there's a different way to structure loops like this, and that is just by using something called a break. Some programmers like it, some programmers don't like it. So if you want your loop to run for sure, what you can do is you can just say while true. The while true means it's going to do it, right? Because remember, whatever I had up here for the condition, a flag is not equal to -1 or whatever, word equals hello or something like that. It always is checking that comparison and saying, is this true or is this false? If it's true, they're going to run the loop. If it's false, it's going to not run the loop. So this case means it's going to run the loop at least once. But because it's true and this isn't going to change, the true is never going to change because it's not a variable. It's just Boolean. This is where you run into the opportunity to run infinite loops. Because if at any point inside your program here you don't run a break command, it's just going to keep looping forever. So you have to have, if you're using a while true, you have to have logic in here to check when it needs to break. So in this case, we know it's going to run because it just says, it just says while true. I don't need to have this flag anymore if I'm doing it this way. I can just say num equals enter a number to print, and you should give them some more information actually, and -1 to stop. I guess in this case is what we had. And now what we're going to do is we're going to just put in a little if statement in here. And our if statement is going to say if num is equal to -1, okay, then we know we need to break. And you always want to have a break into your program. In fact, a lot of people put their break in right away. Sorry, it doesn't need the colon. A lot of people put their break in right away just to make sure while they're building their statement or when they're building whatever's inside the while loop, just in case they forget to put the break in, it's going to break right away. So some people put that in right away and then they just erase it when they're happy with what they've got for their logic. And if number is not equal to -1, we're going to print the number. So this case, it's not going to print the -1. It's going to know that that's the switch or flag that says stop running this loop. And because it's going to break the loop before it prints it, it means it's not going to print the -1. It'll print all the rest of the numbers, but it won't print the -1. So if I run this loop, same program, works the same way. I'm going to type in 6, I'll print in 4, I'll type in 9, and now I'll type in -1, and you'll notice it doesn't print the -1 down here, okay, because I have logic in here that says if they type in -1, break. And all break does is it just breaks up of the loop wherever you are and goes down to the next program line. You notice that you will see the numbers over here. That's the way it is in Python all the time. It shows you on the interpreter what they typed in. But this is not it printing 6. It's the next line where it's actually printing 6. So you see it print 6, 4, 9, and that doesn't print the -1, and now your program's over. So you could use a while true if you want, but make sure you have a break in there. And that can get you out of some certain logic problems at times. Some programmers really don't like using this. They think it's kind of cheating. But I don't mind. It works, and it can sometimes make your code more efficient. So that's a way that you can use while in a couple different ways. Remember that you can also, your logic doesn't always have to be numbers. Your logic can be strings too. So if I just have a straight input, enter any number to print, and then type, stop to stop. Now I remember anything is, unless we tell it to be something other than a string, any input is by default a string. So if I ask them for a number to print, they can type in the number 5 and it'll still print it because the character 5 is still a character. You just can't do any math with it. But in this case, we don't need to do any math. We're just displaying it. So I could change this just as easily to check, instead of it being an integer, check if it's the word. What did I say? Stop, all in lowercase. So if num, I guess I probably should change that to word. Nah, num, because it's still asking them to enter a number. If number is equal to stop, it's going to break. Otherwise, it's going to print whatever they typed in. It's just going to be string this time instead of a number. So if I put in 5, it's still going to print a 5. It's a string. We know behind the scenes it's a string now. It's not actually an integer. I can type in anything I want. I can actually type in words. I can type in whatever I want. And when I'm done, if I type in stop, it's going to end because of this chunk of logic here. If num equals the word stop, then it breaks, which means it goes down to program finished. So there's while loops and for loops in a nutshell. That took about 45 minutes, a little longer than I wanted it to. But if that felt quick to you, go back and go back and watch the video I made from Friday, the live session for Friday, because I do lots of examples of fors and lots of examples of whiles and get into much more detail on that. So it's a good idea to go watch that. If what I did today makes sense and you're reasonably comfortable with it, when you're watching that video, just put it at 1.5 speed or 1.7 speed, and just make sure you understand all the examples that I've done along the way. Now, 4.6 was something that was a lot of it was included in the first unit exam because I had this as part of 4.2, I believe, either 4.2 or 4.3. So some of this is review, but some of it's just a couple more things you can do with strings. So this 4.6 is actually really quick. And on Wednesday, we're going to move into 4.7, which is definitely going to take a couple of live sessions because lists are really, really important in computer science. So we went through the idea that there's index positions for every character, and you can go forward or you can go backward by either starting at 0 and going up or starting at -1 and working your way back to the beginning. We haven't done some of these built-in functions with strings, so I just want to give you an example of what's going on here. We're going to make this one a bit more dynamic in that we're always going to ask for an input. So we want to build our programs so that they solve general situations right now. we're kind of past the point where we want to hard code things in, like x equals 5 and y equals hello and stuff. We want to get to the point where we're actually getting a lot of input from the user. So I'm going to put in here word equals input, and then type in a word or sentence, and then I'm going to get them to type in some sort of condition, and we're going to use these. And I'm going to change the condition parameters every once in a while, but generally we're going to get them to tell us something. So the first thing we're starting with is upper and lower, which we know how to do already. I don't need the condition for this one, but I'll ask for it anyway. So when we get something from the user, oftentimes we'll want to have to change how it looks. So we should know upper and lower already because they were included on the first unit exam. So if you ever want to take what they print or use, anything that a user types in, but you need it to be uppercase or lowercase, you can manually do that. So if I want to print word.upper, okay, that's going to take whatever they type in and print it all out in uppercase. So if I type in a word or sentence, if I just type in that, have I still got it in a loop? Python input, type in a word. Oh no, this is my condition. I didn't want to do anything. So there it did, took in my ASDF, and it printed out capital letters. It's going to be the same thing with lower. I type in capital letters, okay, and now it's going to print them in lowercase. So upper or lower are relatively easy. One thing you need to understand though, and remember, is that if you don't, if you're just printing it out and you're using upper, this doesn't change the variable. It just displays it that way that one time. So if I print word again after this, it's going to go back to the original. So if I originally type in this is a sentence, it's going to run this line here where it makes it lower and print it out, but it didn't actually change word for good. It just displayed it that one time. So when I print out word again, it's going to print it out with capitals. So it's going to go lowercase, and then it's going to print uppercase again, because I never actually changed what word was. I just displayed it differently. If you want to change what word is, then that's where you got to go word equals. So you're basically taking the original variable and overwriting it with something else. So if you write word is word dot, what did I say, lower on that one? Word dot lower, now you've permanently changed word, so it's always going to be lowercase. So if I run this again and I type in uppercase letters, now it's going to print them lowercase, because I permanently changed word to be word.lower. So make sure you know the difference between just running this command and setting or resetting the variable using that command. If you just print this chunk, it's just going to print the lower. It's not going to permanently change it. Same goes for upper. Same goes for any of the other ones we're going to look at here. All right, so we've got this lower upper covered. Now capitalize and swap case. These are just continued things you can do with it. So let's just type word dot capitalize, and depending on the version of Python you have, sometimes these things aren't actually there, but most of the time they are. So if I capitalize word, it should just do the first character, I think, like a sentence case kind of thing. This is a sentence, and then I run it. See how it just capitalized the T? So it's basically like sentence case. It's just gonna capitalize the first word, or the first line of your string, and I don't believe it recognizes periods, but I'm just gonna check that. So what if I had two sentences? What if I had sentence one, and then period, and then sentence two? My question to myself is it gonna capitalize both sentence words, or is it just gonna do the first one? My guess is probably just the first one. Yeah, so it just did the first one. So it doesn't recognize that a period is the end of a sentence or a question mark or anything. It's only going to capitalize the first letter in your string. So that's what capitalize does. Might be of marginal use. I don't know that I've ever actually used it in a program. And then swap case just goes from upper to lower or lower to upper. So if you have the swap case in there, and I put in the word, let's go upper, lower, lower, upper, lower, the camel case, right? This is camel case. Okay, so now this should completely reverse it. Instead of the T being capitalized, it's going to be the H that's capitalized. So it's just anything that was lowercase is now going to be uppercase. Anything that's uppercase is lowercase. Again, probably pretty limited use of that, but it is something that builds in. Okay. Now you can also find things in a word too, in a string. So if I get them to, what do you want to find? So now I'm going to ask the user to do a couple things. I'm going to say enter a word or a sentence, and I'm going to check if there's a word in there. Okay, and you can use the find command to do that. So I'll have an if statement because maybe it won't be there. So if condition, okay, in. No, it's gonna work, but it's gonna work differently than I want it to. Let's see if this will print find. And then you need to have the thing you're checking for first, I believe. Condition, comma, word. So I think this is going to check and see if the condition is in the word. The condition is just going to be what we're looking for. So let's type in this has an A. That sentence has an A, right? So what are we looking for? I want to find an A. Find condition. Find is not defined. Find condition word. I'm using find wrong is what it's telling me. So, yoink. Obviously, I put something in incorrectly in find. I usually don't use find. I usually use a different method. Value. Yeah, that's actually not what I wanted it to do. I should probably change that in the PowerPoint. Okay, forget about find. You don't need it anyway. If you ever want to find out if something is in another string, it's actually way easier to use this, which is why I normally use it. So if condition in word print, it's there. This is normally what I use. I don't know why I put find in there. It's clearly the wrong. That one had to do with find has to do with something in external files, which is comp sci 30. For print, it's not there. Okay, so it's flexible. Our program's super flexible. They can type in any word or sentence they want. They can check for anything if it's in there. So this is just an if statement. If whatever they want to find is in whatever they typed in, you can print it's there, and otherwise it's going to print it's not there. So we'll give it another run here. Let's say this is a sentence, and what do I want to check for? I'll check to see if there's an A in it, and it would say it's there. So it found at least one A in there. If I try to find an X in this word, this is a word, and I try to find an X in that, it's saying it's not there, which makes sense. And you can do that not just with letters, you can do that with whole words or sentences or whatever. So this is a sentence, and what do I want to check? Is sentence in there? And it'll say it's there. So you can check whether a whole word is there, or a whole sentence, or just one character. That's generally what I use if I want to see if a letter or a word or something is inside another string or stored in a list or something like that. You just use this very simple if statement if one thing is in another. I don't know if I went through the in when I was doing the original sessions on conditionals. So if something in something else might be a new concept. Actually, I do think I did do that because I think I did something like if A in banana or something like that, then print it's there. Otherwise, print it's not there. Obviously, there's an A in banana, so it would print it's there. So I got it doing this. So if A in the word banana, print it's there. Otherwise, print it's not there. I'll just get these out of there for now. A is not defined. If not a variable, A the character. If A is in banana, print it's there. If X is in banana, print it's not there because clearly it isn't. And you can add variables in this as I had before with word and condition. But I did go through that before. I remember having that example. So we've done upper, lower, capitalized, swap case. Find is that. Forget find, do for something in something else. For that one, strip is going to be new. You won't have had to use it before. You may have to use it in one of your assignments, depending on how you do them. Strip just strips out certain characters in a string or blank spaces and stuff like that. So if I have a word, we'll get them to enter a word or a sentence. Both of these. if I have them enter a word, sentence, you can use rstrip to strip things out. So I'll just print the word at the end, or word. Strip. Word.strip. So I'll just type in a word. I'll type in hello there. Okay, and actually what it did is it stripped out anything after the period. So it might be, see if I do something like this. And I've got a bunch of spaces after hello. So you see how it stripped out the blank space in front of hello? Because I put a whole bunch of spaces in before I typed in hello, and it also stripped out the backspace. So in case your user accidentally, leans on the keyboard or something like that and has a whole bunch of spaces in front of it, it'll see. You can see what I inputted up here. What I input up is up there, a whole bunch of spaces, but it only printed out. The word without the spaces. And you can strip out things that you want to find, I believe. I think you could strip out things just by putting in what you want to strip out. So let's say I want to strip out spaces between words. If I strip out, this is just a blank space in quotes. So if I have spaces in the word, this is a sentence. So I got spaces there, right? I believe that should strip them out. No, it didn't strip. Let's see if it'll strip out ease. No, it didn't. Okay, so I was thinking of doesn't work that way, but it is stripping out the spaces. So that is an important thing. Sorry, there's something that I'm forgetting to tell you, and I just want to double check on it. There was something else about strip that I wanted you to know, and I can't remember it. So back to my notes. Strings. Strip. No, I guess that's it. I just wanted you to know that you could strip out spaces. Sorry, I guess I wasn't forgetting anything. Alrighty. So strip will get rid of any annoying spaces that they put in there, but not spaces between characters. So if you have a sentence in there, it's not going to strip out the spaces between the sentences, which is probably what you want anyway. Okay, so that takes care of the strip command. rstrip will strip out on the right side only. That's a good question. So there's other types of strips. There's rstrip and lstrip. That was a good question there, Maria. So if I'll just hard code this one. Word equals space. Whoops. Word equals space. Hello space. If I print out word rstrip, it's going to strip everything on the right, which means it's going to get rid of all these spaces. So that's specific. It's a specific type of strip. So strip sprint gets all the ones on the front and the back. Rstrip will only strip on the right side, and lstrip will only strip on. You see how it's still got the spaces on the left side here, but it did get rid of all the spaces on the right side. And then the opposite is true for lstrip. It'll strip out everything on the left side, but it won't strip out these spaces on the right side. I can't put another character in there to show you because it's got to be blank space on the other side, so I have to highlight it to show you. So good question. Strip will get them all. Rstrip will get the right side. Lstrip will get the left side. Why can't you do something like a condition equals X, print Y? Print Y. If condition equals X, print Y. What is X in this case? I guess I need to know.
No, what I mean is that whenever I'm doing like an if statement with a condition or with an equal sign, like if a word equals something, then it's always giving me an error.
Yeah, you should go back and review the section on comparisons, because this is why it's giving you an error. You've got if, let's just say, x equals 5 and y equals 2. If you're doing something like this, right? If x equals y, print, equal, correct? So the reason that that's not going to work and you're going to get an error is because you have only one equal sign. If you're comparing something, you need two equal sign, because one equal sign means you're trying to assign a value to a variable. So that one's already taken. So you need to have two equal sign every time you're checking if something is equal to the other. So now in this case, it will not, it will obviously print not equal, but let's say that y and x both are equal 5. Now it'll print equals because you've used these. So it would be in your best interests to just go back and check that part of the video for the live session, where we go through greater than equals, less than equals, equals, not equals, and or, and not. I think I probably spent like 15 or 20 minutes on that, and I can't remember which video it is. It might be the second one. But there's some more stuff like this that if you're having trouble with your comparisons or your condition, it's probably just something very minor like that. You're just missing an equal sign, or you're missing a bracket somewhere or something like that. Does that make sense? Yeah, no worries. Okay, so we took care of the strips, took care of R strip and L strip. Thank you for bringing that up, Maria. So I'll put strip, L strip, and R strip. There's a ton of other string functions. I mean, the list of string functions is huge, but I've only used, maybe 10 of them in my life. But if you needed to do something relatively novel and it's not a common thing with a string, just Google it, because almost guaranteed somebody has built a function for that. If you're creating something that truly has never existed before in any form, that's cool. That's good, because there's just so many people that have coded so many things and added so many functions and libraries to Python. There's very, very few situations I've ever run into when I actually have to code something meaningful for a client or something when I used to work in the industry that nobody had ever heard of what I'm trying to do before. And no, what are you talking about? Nobody's ever done that before. Usually you get some, you find a forum somewhere where they had something similar, and then you could utilize somebody else's function, giving them credit, of course, or use that function to build your own function. But very rarely did you have to work 100% from scratch in order to build something. But you did have to be careful about copyright. I mean, obviously, you're not going to be copying people's code from, even from a forum or a website, and either, not giving them credit or asking them if you can use it, or paying for a license or whatnot. But in general, people in the coding world, especially the amateur coders, are very, very willing to share their knowledge with people. They wouldn't post responses to questions on forums if they didn't want to help people out. So generally speaking, if they've posted it in a forum as a response to a question or somebody that needs help, that information's kind of free game. But if you use it without putting your own spin on it or changing it or using it for inspiration, you should give them credit in your code. And you do that just in your code documentation, or by indicating with a comment inside your code that I took this from Sunil J. and in 2016 or something like that from this website. So it's just like in English or history. If you use something from somebody else, even if it's not word for word, but it's their idea, you have to give them credit for it. Yeah, exactly. And that's why I'm so strict about copy and paste in this class, because theoretically you probably could find most of what I'm asking for on the web somewhere. But if you're copying and pasting something, you're never learning it. Right? You're never learning it, and you're stealing from someone else. You're taking someone else's idea, and whatever. You might get away with it for a while, but after sooner or later, it's going to come. Your chickens are going to come home to roost, as my mom would say. Sooner or later, you're going to get found out. And you're either going to get kicked out of a class or kicked out of school, or someone's going to sue you, or you're going to get fired from your job. So it's better off that we learn early. Don't rip off other people's work, because it just comes back to haunt you later in life. Okay, for a specific letter in a string. This I went through this already. This was the one that I wanted to use for find. So this was the if, you know, if string and or sorry, if word condition in string word, sorry. Right. There. Right. So this was just this one. You know, let's say the condition. What we're looking for is, and the word is this. So if the condition if is in the word and it is, then just print it's there. So that's what I was talking about for. Oops. If condition equals is word equals this condition in. Oh, what do I have a function there? Sorry. Condition in word. Brackets, always something simple. It's there, and it is there. But if I look for x, e in this, it's not there. So it's not going to do anything because I don't have an else on this one. So we went through that before, but that's what I meant for if you're looking for a specific letter in a string or a specific other string, chunk or something like that. That's what I would use. I would use an if in. Orden character. Okay, so these are used if you need to have like a numerical representation of a character, and this is just for characters, not for entire words. If you need to have a numerical representation of your character, it's something called Ascii and some standardized number format. I can't remember what it stands, but there's Ascii codes for each letter, and there's also Ascii codes for special characters and symbols like the Celsius sign and whatnot. And those can be referenced with numbers. And I believe at one point I did put this on the screen, a list of Ascii characters. Here's the Ascii values just for the letters. There's also for symbols too. So lowercase a is 097, which is just 97. There's binary representation as well, but we're not going to do binary in this course. It's in 30. Capital A is 065. So remember, I can't remember if this is in the last video on Friday or if the one before. I think it might have been the one before. Remember that actually lowercase letters are worth more than uppercase letters. Okay, so uppercase letters, the capital A is only worth as a number 65, whereas a lowercase a is 97. So it might be a bit counterintuitive that that a lowercase a is kind of worth more than an uppercase a. And also remember that you can add 26 to any of these uppercase Ascii codes to get to the equivalent in oh, sorry, no, it's 30. It's 32 because there's some special characters. So if you add 32 to 26, you get to 97. If you add 32 to 66, you get to 98. So if you ever want to turn a lowercase into an uppercase using Ascii, I'm not actually sure why you would want to do that, but if you ever did want to do that, you can just add 32 to the Ascii code for the uppercase, and it'll give you the lowercase. I think I heard a question pop up there. Oh, you can't see it, can you? Sorry. I'll just go back and quickly do that again. Thank you to whoever said that. Sure, no. You see it now? No. Okay. Just 1 second. Oh, God, don't show that. All right, now I think I got to figure it out here. There we go. All right, now you can see it, right? Okay, good. So I believe it was the live session before the last one. The last one everybody was at anyway. There's Ascii codes for letters, basically a numerical representation of letters, and the lowercase letters are actually worth more than the uppercase letters. So if you're doing things alphabetically, a capital A would be before a lowercase a. And so would a capital B. A capital B would be before a lowercase a, because a B is worth 66, and that's a lower number than 97. You can always get from the capital to the lower by adding 32, so 67. A capital C, basically, plus 32 is going to give you 99, which is a lowercase c, and then the opposite is true too. If you took a lowercase c and subtracted 32, then you'd get an uppercase c. So just the important part is it's like a numerical representation of a character. So if you ever had to use ASCII codes for any particular part of your program, or if it made more sense that you had, if you were counting by letters or something like that, that you understand that every symbol and character on your keyboard has an ASCII code, and that includes special characters like Celsius and you know, the Celsius sign, and you know, arrows and things like that, things that you can, you know, access on your keyboard, or maybe you can insert a symbol in Word. They all have an ASCII code. All right, so I'll go back to my Python, and you can access those by using ORD and CHR. And this is only for characters. Remember, you can't do this with entire strings. It just has to be like one letter or one character or something like that. So let's use this. Let's enter a word, and then we're going to print the ASCII value for that. For always include as much as you can that's flexible. ASCII value for word is, then what we're going to do is we're going to put ORD word. So ORD, it means ordinal, I think, and it's just going to give you the ASCII character for whatever the person typed in, as long as it's a character. So if I type in, enter a word, A, hopefully it gives me 97, right? The ASCII value for A is 97, and that makes sense. That checks out. And if I do a capital A, it should be, what was that, 65? 65, and I'm going to test it with a string, but I don't know what's going to happen. Yeah, it breaks. It's only for a character. And what's the ASCII character for a 5? It's 53. So that's kind of weird, eh? The ASCII character for 5 is not 5, it's 53. Let's see if 6 is 54. 6 is 54. Okay, so cool. I actually didn't know that before. 0 is 48, 1 is 49, 2 is 48. It's you know, that's the way. That's just the way it numbers them. I'm sure there's some logic behind that. I don't know what it is. Let's try the greater than sign, see what that is. Okay, greater than sign is 62. Is the less than sign 61 or 63? It is 60. There. What number would have 0 as ASCII? Oh, let's find out. So we can go the other way too. We can get. Okay, so enter an ASCII code, and then let's find out what the character is. So now you just go opposite, right? So the character for blank is, and now instead of doing OR, you do CHR. So let's find out what 0 is. So we're going to ask what ASCII character, or enter an ASCII code. I'm going to type in 0, and it's going to say drop get type string. The character for word is CHR word. Oh, this needs to be an integer. Sorry. Yep, makes sense. When I was looking for the word, it was supposed to be a string, but now that I'm looking for a number, it needs to be an integer. So I need to find the character for an integer, not a string. It doesn't know what 0 is if it's not an integer. All right, so what's 0? The character for 0 is a blank space. So the blank space is a 0, and 1 is that little square box, whatever that is. 2 is, there's something there, but I can't see what it is. So it's probably something that just can't be represented with the fonts I have installed here. 5 is, and something else that can't be displayed. Let's hope that we get some letters here. Yeah, 97 is A. 245 is that sign, whatever that is, an O with a little thing over top of it, probably from some Spanish or Portuguese language. But anyway, there's lots of them. I don't even know how high it goes. Try 1024. Obviously it goes past 1024. Try 10,000. That's something, but I don't know what it is. I think it just kind of puts a box in here if it doesn't know how to display that character. But anyway, that's how you can check out the ASCII values of a character, but it's just got to be one character. Or you can take a number and then figure out what the character is for that, right? So we could use that in a loop, I guess. We could use that in a loop pretty easily. Let's say they enter an ASCII code, and we're going to print the next 10 things that start with that letter. So let's enter an ASCII code between 65 and what was the end of it? Hold on, gotta find the end. Capital Z is 90, or sorry, 122. Lowercase z. That's what I was looking for. So enter something between 65 and 122, so that we know it's actually in the alphabet, and then we'll print out the next 10 letters. Okay. So our output. So let's create a temp string equals, and then I'll make it nothing for now. And then we'll do a quick little loop here. Okay, so I'll do a quick little loop that says for, what am I going to be giving here? I'm going to be giving a number. So for x in range, word, so that's going to be a number. And then I want to add the next 10 things, right? So in range from word to word plus 10, plus 11 actually, if I want the next 10 things. What I'm going to do is I'm going to go temp string, and then I'm going to add to temp string each of those characters. So whatever they type in between 65 and 122, that's going to be the here, right? So let's say they type in 65. So your range is going to start at 65, and then it's going to go to 65 plus 11, which is 76. So what it would do there, it would take whatever character is at that particular place, whatever x is. If x is 76, it's going to take whatever character is 76 in ASCII, and it's going to add it to your temp string, and it's just going to keep doing that. So the way I've got this set up, it's going to start at the number. It's going to go to 10, the next 10 numbers, or next 10 letters, sorry, it's going to be, and then it's going to keep adding that to temp string each time. And then at the end, I can just print out temp string. So the next 10 characters after word, which is car word, CHR word. So the next 10 characters after whatever they type in is temp string. Always got to remember your quotes is, comma, temp string. So the entire time I'm running this loop, I'm essentially, I got something wrong here. Next 10 characters after character word, comma, is string. Too many brackets. Yeah. So basically, all this is doing is going to take it letter by letter. So if I put in a B, or the ASCII character for a B, which is an uppercase B would be 66, it should be taking temp string, and it should put that letter plus C plus D plus E, the next 10. I've got it to start at whatever the word or whatever the number they enter is. So if I don't want that letter in there, I should actually start at word plus 1. Okay, so if I put in 66 and I just had word, it would put 66 as one of the characters, but or put B as one of the characters, but I actually want to start with the next one. So it would be the B plus 1 is a C, and then the next 10 after that. So I guess this would have to be word plus 12 in this case. Yeah, let's see what, no, word plus 11. Yeah, word plus 12. So let's see if it works. Okay, so let's enter an ASCII code, and let's start with something we know. So 65 should be a capital A. So let's put in a capital A, and it says the next 10 characters after A is a whole bunch of A's. Now, why did it do that? For X in range, temp string plus character of word. Oh, character, sorry, hold on, missing something here. So word's a number for X in range, word plus 1 plus 12. Temp string character. Oh, sorry, it should be character X, because X is going to be whatever the number is. So X is going to be 65, and then X is going to be 66, and X is 67. I just printed the character for this the entire time. So they said, hey, start after A, and I said, hey, print A a whole bunch of times. So that's my mistake there. All right, so let's try that again. If we type in a 65, should be a capital A, so hopefully it types in B, C, D, whatever. So B, C, D, there should be 10 there, right? Hopefully. That's 5. Did I get 11? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I got 11, so I needed this to be word plus 11. Now this will print out the next 10 characters. So if I type in an A, I should type, oops, good grief, Dunbar, you got to type in a number. If I type in 65, should start at B over here and go to K. That should be the next 10 letters. And I don't have to start at A, right? I could start at, let's start at 70. So 70 is an F, and the next letters after F in order are G, H, and blah, blah, blah. And if you start at 100, that starts at a lowercase d, and then it'll print the 10 after the D. And you could probably get some wacky characters if you start before 97. So if you start between, if you start a couple before 97, you'll get some weird characters. So if I type in 91, you'll see I've got, so 91 is the left square bracket, and then 92 is that, 93, 94, 95, 96, and then we get to 97, which is A. So between 65 and 122, there are some different characters that aren't in the alphabet, but not many of them, because the last lowercase letter is, last uppercase letter is 90, and the first lowercase letter is 97. So there's going to be 7 characters in there that are not part of the alphabet, and they start at 91. So if I run this again and I type in 91, these are all the special characters. Yeah, so that, what is it, 1, 2, 3, 4, 5. I feel like there should be more than that. What's going on here? 89. Okay, so 1, 2, 3, 4, 5, 6. Yeah, 6, that makes sense, because that's 90, and then this is 97, 91, 92, 93, 94, 95, 96, and the lowercase a is 97. So there's 6 symbols that are wedged between the uppercase letters and the lowercase letters. Okay, probably more than you need to know about that. But temp string, using temp string to build strings is actually quite important, because I don't print it out 1 character per line. If I use this for loop and I just print out, if I just print out the CRHX or CHRX, and then say I start at A, it's going to do one, well, I don't have temp string, so I print CHRX. But if I just print it inside my loop, it's doing one thing per line, which is annoying. So if I type in 65, see how it's printing them out one in a line. And that's not a handy way for you people to read things. And I have several programs where I ask you specifically to do it this way because it's easier. But building a temp string and then printing it after the loop is a really good way that you can build words, build sentences based on what the user types in, from grabbing things from a list or whatnot. So this is a skill that I think is important, is being able to take a temp string that starts with nothing and then just add the things that you want to add. So the next characters after that are temp string, and then, whatever, I start at 89. The next 10 characters after Y is C. Why don't you just do 89? Char X, X in range. Oh, plus equals, not equals. Boink. There you go. And this would work for words as well. Or you could skip letters, right? This is a range, so you could skip by 3. Let's say, so the next 10 characters skipping 3 after blank are these 3. So let's put this up to 20 or something like that, and then it's going to skip them by 3. So if I put in an A, it should skip B and C and then go to D. What's wrong with that? Oh, why did I put in A? What I meant was 65. So it's going to go B, and then it's going to skip C and D, and then it's going to print E, and then it's going to skip E, F, G, and then it's going to go H. So it's skipping 3 every time. So that could be handy if you need to skip over letters or get every 5th letter or 7th letter or something like that. I don't use character or a whole lot, but it is it is something that can come into play with programs, not specifically in this course, but maybe in the future. So it's useful. All right, that's what I had today. We're at about a minute 20 so, and that should be good. Does anybody have any questions? I probably did a little bit more on looping than I wanted to. So again, if you find that there's quite a bit of repeat in that video I recorded on Friday and posted on Friday, just maybe run through it at a faster speed. That should get you through a assignment 12, I don't know if there's a whole lot of lists on assignment 12, if any at all. So I think you're good for assignment 12 now. You should have everything you need. And then we're going to start with lists on Wednesday, which means that after Wednesday, you probably have just about everything you need to complete all of the remaining assignments. We do have one more thing on 4.8, which is try accept. But if I have an assignment on that, it's a very minor one at the end of assignment 13, and I'm actually not sure I do. I think I just have a couple of try accept questions on the second Python exam, and you'll know it in plenty of time for that. So, are there any questions? Anything not making sense or that you need help with? Do you have temp strings or temp string? Okay, look at my code. My guess is you've probably got just one thing spelled incorrectly, or you're missing one bracket or something like that. I'll bring it back to what it was. I think it was this. Just check things over very carefully, because usually the error is something very minor. And look at the error too, because it'll probably try to give you some information down here if you make an error. It'll probably try to tell you that it doesn't know what temp string is, or don't you need a comma after the is? Yep, that's your problem right there. Nice catch there, Zion. Up here in your code after the CHR word, and you've got a comma is, but you don't have another comma. That's probably the error. Nice catch. No worries. All right, folks, you have a great day and week, and hopefully I'll see you on Wednesday. And as always, send me an email if you have any questions. Take care. You too, Maria. You too, Janet. See you, Zion.